Hey everyone, welcome to Inside the AI. I'm your host, the Data Doc, and today we're going to be going through Google ML Notebook. I want to explain what it is, and then I want to talk through what a RAG system is, what a Retrieval-Augmented Generation system is. Essentially, that's what Google ML Notebook is. The reason I'm doing this video is I want to do a deep dive so that I can continue to learn, and you can learn from this video. It's going to help you in building out N8N workflows. So linked in the video above is a video on N8N of how to create a RAG system that automatically updates itself and deletes old, outdated information. So follow that video for a step-by-step guide on how to build one of these out. So now let's dive into what Google ML Notebook is. And essentially, it's a large RAG system. We have sources on the left that you can update. We have an AI chat model in the middle. And then we have outcomes on the right of what we can do. So now let's talk through first our sources. I've updated some sources, but I want to show you how the sources work. Essentially, all you have to do is add, and you have your mechanism of updating your system. We can drop in a PDF, text, anything we want here, and this will automatically grab it and pull it into the system. We can link it to our Google Drive and update it through our Google Docs and slides. And we can copy and paste text. Two pretty interesting things is we can link a website to it. So we can copy the URL and add the website here, and it will add that website as a source. But what I want to show you is how I updated these from YouTube videos. I'm going to go to this YouTube video, and I'm going to copy the URL. And all I have to do is click YouTube, paste it here. And it's essentially what I see it doing is it's going to transcribe the YouTube video, and it's going to add it to our sources. So with that added, now I have all these sources updated. If you noticed across the bottom, we have the maximum amount of data we can add to this. So essentially what this is doing is it's creating a database that it's going to allow the AI to call, which is pretty interesting. So now what does the chat model do? So this is an AI system, and we can ask it questions. We can ask it to make a mind map. So I'm going to click this so it can start working here, and it's going to create us a mind map. We can tell it to give us some information, and we can add notes. I'm not going to do any of these. I'm going to just ask it a question. So we're going to ask it, what is a RAG? And so now it's giving me information, right? And so some of this information, it says, hello, I can help you analyze the information. But let's go through right here what a RAG is. So essentially what a RAG stands for Retrieval-Augmented Generation. It's a framework or a pipeline that enhances large language models, or LLMs. The main purpose is to provide LLMs with external, up-to-date, and domain-specific information that the model has not originally been trained on. So this is very important. I want to talk through this a second. So it provides an external database. So if you're an organization with a large volume of data and documents and policies, you can create a standardized database that the large language model has not been trained on, and it will call information from that database. It's important to know that the limitation is that it does have to be updated. So if you start to let this get outdated, what's going to happen is you're going to get wrong information. So you have to update this. And with these systems in N8N, we have a process that would automatically do this. So it will delete old information and create new information in AI models that we've created. And then they're domain specific. So by using the RAG systems, we can use LLMs that are grounded on the response. It provides a more accurate response, and it's concrete information, which proves that the reliability and reduces the hallucination. Hallucination is very important because it generates false results. So what we want to do is reduce this as much as possible. And the way we do that is if we have a system which is an external database on our own information, we can trust the AI is not going to make up information from stuff on the internet. So now how do RAGs work? So a RAG system typically involves two main phases: indexing, which is offline, and retrieval, which is online. So indexing is an external document or database. So basically we're taking Word documents, PDFs, and any of those type of information, and then those are going to be broken up. So the documents are then broken up into smaller pieces or chunks. The chunks are then sent through a embedding model, and then the embedding model is used to convert the chunks into numerical representations, which are called vector embeddings. This is where vector databases are coming from. So these vector embeddings are stored in searchable indexes, commonly referred to as vector databases. This process makes the domain specific. So basically what we're doing is we're saying we have a large volume of information. It's taken in, it's broken up into smaller chunks. Those chunks use a mathematical equation to label them through numbering, and it ranks them based off of that information. And then when you go to call the information, the AI will retrieve the most important information based off of those numeric values. So now what is the retrieval and generation phase? This is a user provides a query or a question. So basically the retrieval phase was when we sent in this question for it. The RAG retriever then takes the user's query and converts it to a vector using the same embedding model. So it uses that same model to create a numeric value to then match it to the numeric values that are inside of your database. A similarity search is performed in the vector database to find the most relevant documents that are chunked up. The retrieve context is then added and augmented with the original query to create an enhanced prompt. This augmented prompt contains both the user's questions and the relevant context for the knowledge base in the LLM. The benefits of this. Key benefits of a RAG is that the data is fresh and the information is fresh. It's up to date as long as you maintain that database. It's domain specific. This enables the LLM to answer questions that are private to your company, that are proprietary to your company, and that they won't be trained on. Another big example, another key benefit is that it reduces hallucination. So all of this is grounded on key facts, your information, your company's proprietary information, so you can trust that the AI is gathering the right, accurate data. Traceable. This is very important. So all of the information is cited. So if you see here, we have citations of where this information is coming from. So this RAG database is actually giving you the sources where it's coming from. So another one is scalability. You can knock these out really fast. Models are very scalable. It can handle large amounts of documents, and it can retrieve small relevant information within those documents. It's cost effective. Rather than fine-tuning, which retunes a whole LLM, this method is going to allow you to target your specific data. So now we're going to do a little different technique here. I want to go to the LLM engineering mind map. And now let's talk through how this works. So now we're going to go through prompt engineering and AI model optimization. So prompt engineering is going to be defined as designing questions for LLMs to get desired responses and avoid hallucination. So essentially, there's different things you can do, but a prompt engineer is asking it a question, the best question that is designed to that AI model to get it the best result and avoid the AI from making up information. We have a couple of techniques here. These techniques are called chain of thought, react, and directional stimulus prompting. These are important to note. I'll do a different deep dive on these if you would like, and we'll go through what these are. Some of the benefits of a prompt. We see that there's no infrastructure charge. So basically, it's as good as your knowledge. You get immediate results. If you have bad data, if you have a lacking model, a good prompt will overcome that. And it activates existing capabilities. Sometimes you have capabilities in models that you don't know about. So having a really strong prompt will allow you to leverage those capabilities. Although there are limitations, and so some of the limitations are trial and error. You do have to test these things out. So as you're making these prompts, it's great to use, but you have to test them out to see what works best. So these RAG systems are also limited to existing knowledge. It's not going to be able to call all kinds of information from all over the place. It's going to be centralized to the data you provide it. And you cannot add new information, although this is actually false. You can continuously update it, but you're not going to get the information until the RAG database is updated. So now let's go through what the RAG system is. So a RAG system, its definition is enhances LLM's response by incorporating relevant data from external knowledge base and adds data as context to a prompt. All of this information is grounded, which means that information is grounded in the data you give it to provide a more accurate response. The process is a two-phase process. The first phase is offline, which is indexing your data. And this indexing is known as ingestion knowledge, which is documents and PDFs, then breaking it into chunks. So you have your documents and PDFs, which are broken into chunks, and then it creates a vector embedding. So this vector embedding is a numerical value, which chunks up your data into smaller chunks and gives it a number value and ranks those information. It stores all of that into a vector database, which allows your LLM to search those by the numbers rather than the words. The online method is the retrieval and generation. So the user can have an input. That input is then turned into a vector by the RAG retriever. So you have an input, it gets sent to the RAG retriever, which then numerizes your input. That input matches it to similarities in the vector database. It returns the K-relevant document. What that means is your data is chunked up, and then it's giving a numerical value. The K is the probability of your query being what the data was retrieved. The chunk is added to the LLM context, and then the LLM generates a response based off of the context. That's how it works. So now let's talk through this phased approach. So we have two systems. The query is sent to the LLM, and the LLM queries the external database. The external database is the one you've created. It retrieves relevant information and combines that information for the user's question to generate an answer and provides the evidence of the response. So what are the benefits of a RAG? So the benefits is it improves the accuracy. So the benefits are it improves accuracy. It has more up-to-date information as long as you're updating the information, and it reduces hallucination because you are only calling the relevant information that you've provided it. It's less reliance on training data. So all these systems are being updated. It's not going to be reliant on the data being trained. It can be domain specific. So if you're a doctor, you could upload only relevant material and it's relevant to your domain of knowledge. Modular systems, we can swap in and out pieces of this system, and it's very flexible. It supports citations and it's very scalable, and we can add more knowledge. Some of the limitations though. So the limitations within a RAG is the performance costs and latency. What that means is we're adding another database. So if we are querying a large language model that's trained on its own database, that's one information search, right? Now what we're doing is we're asking the model to cipher through another set of data to return that information to us, which then creates a little bit of a delay in the process. The processing costs, vector embeddings and databases, we have to have the processing costs. Vector embedding and databases, this is a new infrastructure cost you're going to have to pay for. You're going to have to pay for a new database, and you're going to have to pay for someone to maintain it. Retrieval, quality, impact, and accuracy. And you can say, I don't know. So you can provide the AI a method to say, I don't have that information, and it will not hallucinate. So naive RAG processes. So indexing is breaking up the large data into smaller chunks and then vectorizing them into the vector database. The retrieval, the user puts in an input, it retrieves relevant data from an embedding model, and it provides you the syntax. The generation, LLM uses retrieved context into a formatted response. So now let's talk through current meta. So now let's talk through the framework and tools. So we have a few different framework and tools. We have Llama indexing. This is a general RAG framework. which is Llama Parse. Hugging Face, this is a fine-tuning embedding model. Cohere, a RAG optimized model. Re-ranking and embedding model. We have Microsoft GitHub, and we have Raga. If you found value in this video, please like and subscribe. Stay tuned for my next video where we're going to be talking through a vector database. Write comments below on what you think I should do the next video in.